So I'm not going to double up next semester or next fall. I mean,
But you don't have to take all your gen ed.
pretty sure I had all my pre-regs.
Yeah,
for
if you
it.
drop honors, you have to go back.
Yep, you do.
I clear all my gen eds with the pre-regs though.
Yeah, if you you have to go back and take out, make sure that's all taken.
I hope my 30 credits I transferred in when I came to Morgan would clear those pre-regs.
Yeah, Marshall, we can go through and look at it if you're really interested in doing that. I have no issues doing that.
I gotta get through Hartzog first, figure out what he's gonna do first.
I feel like they should definitely kick a sophomore out of 350s. Like, they have so much time to think about.
Why are they letting the sophomores take it anyway?
I know.
Some want to graduate early.
Too bad.
Well, then they could take
What's that?
I already took mine earlier.
I feel like Milliken's like really against people graduating early because they want all the money they can get out of every day. So I don't know why they let people
And our
do that.
class isn't even full because it's so boring.
Sorry.
350s suck. Yeah, so I'm in a 350 right now.
What are you taking? Human nature with Herzog?
That's why I'm saying nobody
Well,
wants
I'm
to
in
take it.
democracy and it's critics, so that one's.
That's not even.
I'm in theater of resistance.
So you're saying is I should put together an honor set?
Yes.
Yeah, and then I'll drop a line now and take this.
I'm a bad kid in theater of resistance. I can outboring all of y'all.
Yeah, if they hadn't canceled international trade and put a theater seminar there, I probably wouldn't be in that situation. But hey,
Here you are.
Here you are.
too late now.
Sorry.
I can't be mad at you, Dr. Joe. You didn't do anything wrong.
I totally messed it up on Chapter.
Well said. I said, I know Dr. Joe screwed up, Dr. Hartzog.
That's right.
Please do me a favor.
Yeah, no.
I did tell you yours was fixed, right, Nick?
Yeah.
Okay, good.
We should definitely put human in.
All right. Let's see if we can work through that third one. That was this number 3, because we did talk about this last time with dollar weighted, and then we'll talk about how we do time weighted. Dollar weighted was the last thing that we did. So let's talk about how we do that.
Okay.
Sound like a plan?
Yep.
Okay. So for dollar weighted, try that again. For dollar weighted, remember we're trying to figure out what would be the overall yield for the account for the entire year. We could do that with the internal rate of return. In this case, and with our cash flow idea, because in this case, if you're trying to do internal rate of return with, just trying to solve it, we've got 1, 2, 3, 4, 5 cash flows, right? You've got an initial balance cash flow, a withdrawal, a deposit, a withdrawal, and then an ending balance. So that's also considered a cash flow in these internal rate of return problems, right? You'd have 5 cash flows, which means you'd have a 4th degree polynomial that you're trying to solve. While not impossible to do by hand, it would suck a lot. So you could do it with your calculator. If you did it with your calculator, we talked about this last time, you could do it as monthly cash flows, because we've got here at time 0, this would be at time 2, end of February, beginning of March. This one would be at time 6, end of June, beginning of July. This would be at time 10, end of October, beginning of November. This would be time 12, end of December. Right? So we could do the cash flows using a monthly idea. Actually, if you're clever, you could do it by 2 months, because this would be a 2-month period, and then a 0 for the next 2-month period, then another 2-month period, another 0, another 2-month period, and a 2-month period. So you could do a 2-month interest rate too, with using your internal rate of return, if you wanted to be clever. We don't want to be that clever, okay? At least, no, I don't want to be that clever. Okay. So when we're doing dollar weighted return, this is when we do the simple interest approximation for the interest rate. So for example, just to talk about what we mean by that, this $1,000 that's in there at time 0 is going to earn interest for the entire year, right? So we know what it would grow to. We would subtract off this withdrawal, because we're going to take that out at time 2. So we'll lose the interest for that 10 months. We would gain the interest on this $70 for this 6 months. We would lose the interest on the $120 for those 2 months, right? So when we set it up, and usually we just remember the formula, but when we set it up, we know that if we take, this is all fun. when we take the 1,000, apparently I'm still in red. That 1,000 is on there a year for simple interest, and this is our simple interest accumulation factor, right? We agree? Okay. We would subtract off the 50, and it accumulated for 10 of the 12 months, right? Because it's at the end of February, beginning of March, so from time 2 to time 12, 10 more months, right? We would add back the 70, and that's on there for 6 months, half the year. We would subtract off the 120, and that's on there for an extra 2 months. I don't know why I'm writing 2 over 12 and didn't reduce that fraction, but I did to 6 over 12, but that's neither here nor there. This, when we do all of this, these are the cash flows, right? Beginning balance, we took out 50, we put back 70, we took out 120. We factored in the interest, right? When we get all of these cash flows and all of this interest, what do we have to end up with? The 1050, right? The end balance. So this has to equal 1,050. This is how the setup goes, right? We agree? We still haven't talked about what those balance activities, the balance before activity things are. We're going to do that here. I'll talk about time weighted today. But this is how the pardon me. This is how the dollar weighted works. And I forgot that I didn't hand out. Apparently, when I did the assignment last time, I forgot to hand out this piece of paper with the other ones that I handed out last time. Grace pointed out, so you can thank Grace that I'm giving it to you now. All right. So, anyway, if we think about the whole idea behind this is we want to solve for I. We did this with a simple interest. It's not exactly going to be your internal rate of return because we're approximating the compound interest with simple, right? Because these are all simple interest calculations. But it'll be close because really we're only doing this for a year, right? So the compounding is not going to have that much of an effect. In fact, this is exact. If I is an annual effective rate, this is exactly what $1,000 would grow to for the course of a year. Because the simple and the annual effective are the same thing for that first year. Okay? So this is going to be close. It won't be exact, but it gives you an idea and it's simpler to calculate. So when we solve this, I'm solving for I, so I've got all these other constants to move to the other side. Let's just analyze that for just a second. We would have the 1,050. I would subtract off the 1,000. I would add back the 50, subtract the 70, and add the 120, right? Those would be the constants, right? They're all going to flip signs. So notice what we're doing. Here's end minus beginning. If we didn't have any other cash flows, this first part here would just be how you would calculate interest in the account, right? If you put $1,000 in and got $1,050 out, you'd have $50 in interest, right? So the rest of these are just balancing out what you put in so you can figure out what the interest was, right? We have to add back in the 50 because I took out 50, so I don't want to take that away from the interest, right? I subtract off the 70 because I put in 70. I don't want that to add to the interest, right? Our calculation for trying to figure out the interest. And then same thing with the 120. I got to add it back because I took it out. So this computation here literally is just the interest earned. Does that make sense? So what we've really done here, if I write it out as a formula, if you will, this is ending balance minus beginning balance, and then plus withdrawals and minus deposits. Why am I writing subtraction sign and then write the word minus? That's right? That's what we did, isn't it? Okay. So that's, again, this is just a computation for figuring out the amount of interest. So the other part that we're going to do is divide so that we can figure out what I is. So in this case, our interest earned is what? It's 50, 100, 30 plus 120, it's 150? If I did my arithmetic right. Okay, so this is 150. So when we solve for I, the top will be 150. That's our interest earned. What do we need to divide by? Well, each of the other terms have an I in it, and they've got some coefficients, so I'll have to subtract it. So I needed to divide by 1,000. And just for emphasis sake, I'm going to say it's times 1. I've got minus the 50. We're multiplying it by 5/6, they're 10/12. Plus the 70 times 1/2. And then minus the 120 times 1/6. The only reason why I put the 1 in there is to try to emphasize what's going on. How long did the $1,000 sit in there? The whole year. Thinking about, I mean, I know it's a withdrawal, which is why it's a minus sign, but if I were thinking about the $50 as a deposit rather than a withdrawal, how long would the $50 sit in there? The 10 months, right? 5/6 of the year. Now, it's negative because why? Well, it's a withdrawal instead of a deposit, right? How long did the 70 sit in there? Half the year, and 120 was a sixth of the year. So that's where those numbers are coming in from. Does that make sense? Okay, so all these numbers are on the bottom are your cash flows multiplied by the length of time until the end of the year. So if you look at this in some books, you'll see this as the sum of the cash flow at time t sub I, and then multiplied by 1 minus t sub I. So the cash flow is the C sub t sub I is the cash flow at time t sub I. So for us, if I were just to write this out, I'm only writing this because this is, you'll see this in other review manuals as the formula for the denominator. It's the only reason why I'm even writing it. I mean, if you think about the problem, you're just going to write it out anyway. There's just not, if you're doing this for exam FM, you're just not going to have that many cash flows to have to do. Okay? So you're just going to write it out anyway. And if you think about it, you're going to be able to just write it down. Okay? But for us, this cash flow, your first cash flow is 1,000, where your first time is 0, right? Your second cash flow is negative 50, and your second time is 1/6. Third cash flow is 70. Third time is 1/2. Does that make sense? Where I'm getting those? Fourth one is negative 120. Fourth time is 5/6. Again, I wouldn't even be mentioning this if it didn't appear in the review manuals. Because again, if you just think about where that denominator comes from, it makes sense. At least I think it makes sense. Anybody actually do it?
1541.
15.41?
0.1541.
Okay, so 15.41%?
Yeah.
Okay, cool. We okay with that?
Yeah.
Thrilled to pieces. Cool. All right. So that's how you do dollar weighted. And again, the idea here is all we're doing is taking the amount of interest and dividing it by basically what made it grow. Right? So let's talk about time weighted. So to do the time weighted, let's see if I can move this thing down so that I can see it on the same screen. Maybe. There we go. All right. So for time weighted, essentially what we're thinking about here is growth factors. What I find here interesting is they call it time weighted, and we don't actually do anything with the times when these things happen. Okay? So the idea behind time weighted, and the reason why we don't actually plug in anything with the times, but the idea is that we assume that if something happened during the same time period, it would behave in the same way. Okay? So what I mean by that is, from the time period t equal to 0 to t equal to 2/12, 1/6, this grew by 20%. Right? I'm sorry, it grew by 2%. Try that again. Bad arithmetic. Bad arithmetic. Okay? This grew by 2%. So the assumption that is made is if we made any other deposit, it would also grow by 2% during that time period. Okay? So the way that we can figure out that growth factor the way we would figure that growth factor is that we would take ending balance divided by beginning balance, right? That gives us the growth factor, doesn't it? Or accumulation factor, whichever way you want to call it. Does that make sense? We grew from 1,000 up to 1020, so you would do, well, if you think about the factor, right? Your interest would be 20 and you would add it to the 1,000. So that would give you your multiplier. But it's not unlike those geometric series problems where it said each payment is 4% more than the previous one and we multiply by 1.04. Same idea. Okay? All right, so this is your growth factor from time 0 to time 1/6. All right, the reason why we have this amount is because something else happened at time 1/6. We knew we took $50 out, right? So from time 1/6 to time 1/2, how much did we grow? Or where did we start and where did we end? What was the starting balance at time 1/6 after we took out the withdrawal? 970, right? Because we're taking out that 50, so it's not going to be considered in the growth, right? So it's going to start from 970. What did it grow to by the time we got to time 1/2? 990. So how would we figure out what that growth factor is? What would we do? We would do the 990 over the 970, right? And again, the reason why it's 970 is because we're taking out that $50 because none of the growth is associated with that 50, right? It's been pulled out, so they can't accumulate any interest. It cannot accumulate any interest anymore. It's been taken out of the account. So we subtract it off the 1020, make it a 970. It grows to 990. That make sense? Okay. Now let's do the next one. I can spell the word growth factor. From 1/2 to 5/6, where does the balance start? $1060, good. Because we're going to add the $70 deposit in. Where does it end? 1,100? Does that make sense? And then the last part, for 5/6, wow, that's just a mess. From 5/6 to 1, what do you get? 1050 over 980. Because we're going to subtract out the 120 from the 1100. Everybody see where those come from? Okay, so these are our growth factors for those time periods. Now again, the idea is that we assume that this is an account. If somebody else placed in money into a similar account, they would experience similar growths. Or drops, if for some reason the lost market value. These could be negative. Okay? But we're assuming that if somebody else used a similar account, they would experience similar returns. Okay? So now let's think about what happens from one to the next. It grew by this factor from time 0 to a sixth, then grew by this factor, then by this factor, then by this factor. So if I put in money, I would multiply it by this factor, so at the top 1/6, then multiply it by this one, then by this one, then by this one, right? Just thinking, basically we're thinking about, if you think about it as 4 different accounts, I put it in this account first, I take the money out, then I put it in this one, I take the money out, then I put it in this one, I take the money out, then I put it in this one. So if I multiply them all together, that gives me overall growth rate. Does that make sense? Okay. So our overall growth rate in this case will be your 1020 over 1,000 times 990, over 970 times 1100 over 1060 times 1050 over 980. Just multiplying them all together. And I think Grace is going to help me out here. Looks like Grace is going to help me out. And Sydney and Marshall. See all sorts of calculators going.
You got 1.1575.
Okay. Now notice that this is close. The decimal part is close, right? But we got this extra 1 floating out in front, which makes sense, doesn't it? Because what did we do? These aren't interest rates, these are growth rates. Think about what your growth rate looks like for simple interest. It's 1 plus the interest rate, right? We agree? Okay? So this 1 out in front makes sense that it's here because what we have is 1 plus what's referred to as the time-weighted return. So 1 plus the time-weighted return is this product of these growth rates. So your time-weighted return then will be 15.75%, just the decimal piece. So when you're working problems and just thinking about using a formula real quick, you have to remember that for our dollar-weighted return, that formula we came up with was the interest rate. But this idea of multiplying growth rates together gives you 1 plus the interest rate. Now, it shouldn't be hard to figure out that you've got that if you multiply it together and you get a 1 point something. Your interest rate is probably not 115%. Probably not. Could be, but probably not. Okay. This okay? Does the idea make sense? Let's see if we can do another one here, maybe. That's net present value. We talked about that the other day. Let's do this. Let's do this one. So this is in those problems that I gave out last time. You may need a packet from last time. I thought maybe. You're welcome. This should be in 5.7. The one's labeled 5.7. So it should be on the front page on the right side, and it's number 1.
I have section 5D and 5E already.
You do?
Yeah.
Oh. Well, I made an extra copy. Grace, she says she has it. You don't have it?
I also have 5D on here.
I killed it.
You killed a tree for nothing?
Hey, you checked. You didn't know where it was either.
I was gonna say, I feel like.
Oh, I just assume I screw up.
Because I went through all the problems to circle it, so I get confused, and I was like, I swear.
Well, now you have an extra one. My apologies. Well, Grace's apologies.
My bad.
I do want to talk a little bit about this one besides doing the dollar weighted return. I just hit my head on that pole. Besides doing the dollar weighted return, that was weird. I want to show how we would do this if we were going to do it on the calculator. It's still going. Good. All right. So we've got a fund balance at the beginning of the year of 75 and 60 at the end of the year. We got $10 of deposits every single month of the year, and then there is also withdrawals on those particular times. We want the dollar weighted return. So when we're doing dollar weighted return, what goes on top of our fraction?
Balance.
Okay. Okay. So end balance minus beginning balance, and then plus the withdrawals. So how much in withdrawals were made? So we got 5 and 25, 30, 80 is a 110, and 35 is a 145 if I did my arithmetic. And then how much was it made in deposits? 120. So that gives us our amount of interest, right? So we did end minus beginning plus withdrawals minus deposits. Then on bottom, well, we got a lot of computations to do on bottom, don't we? Okay. We need to, I'm actually going to take care of the withdrawals first. How long was that withdrawal? Well, how much time period do I need to consider that withdrawal of 5 for? That first withdrawal, how long of a time period does I need to worry about for that withdrawal? 10 months, right? Okay, so I'll have a minus 5 times 10 over 12. Right? And then for the 25, a half. So it'd be minus 25 times a half. The 80.
5.4.
Okay. So 5 over 24. Two and a half months. So 2.5 over 12. Right?
There are
Good.
31 days left on it.
We're 1.5. We're not doing it. You could do it by daily if you really, really want to.
It's like just about.
Yeah, we just need to worry about. Yeah, it's half of the month. I mean, you could do these by days. I really don't want to. It'll be close enough anyway. And then the last one is just the 2 months. We agree? Okay. All right, I got to add back these deposits. I'm not going to write them all out individually. I'll do it this way instead. There are 12 total deposits, right? The first one lasts 11 months. The last one is 0 months, right? Because the last one goes in on the last day. Because it says the end of each month. So really all I need to worry about 11 of the deposits. And each of them will be for I over 12 of the year. Just makes my life a little bit easier to compute it. That's the reason why I wrote it that way. Because we know a formula for the sum of the first n integers. Well, at least I do. N times n plus 1 over 2. You've heard that before, yes? Mm-hmm. Yeah.
Couldn't remember.
Couldn't remember it. You've heard it before. So this one is... So when I do the sum from I equals 1 to 11, this will just be 11 times 12 over 2. So really this just adds up to 5.5.
What's the formula again?
The sum from I equals 1 to n of I is n times n plus 1 over 2. All n. I don't get to be over 2. It's all over 2. Okay?
And here's 11.
It's 11 it's because the last one if I put in, remember that really I'm kind of doing it in reverse order. The first one's on there for 11 months, the second one's on there for 10 months, the last one's on there for 0 months, so I didn't bother putting it in there. So that's why we did 1 to 11. Why I don't have 1 to 12, because there's not one that sits there for 12 months. I mean, if I really, really wanted to write it like it would look like in that formula we came up with, you would really have something that looks like this. Right? But when I put in 12, you get 0. So I didn't need to bother putting it in there. And it's basically symmetric because they're all the same. They're all the same value. So you can put all those things in there.
This might take a while.
It's possible it could take a while.
I got it.
You got it? What'd you get?
Hair over 11%.
Hair over 11%? See other people typing just to see if anybody gets the same thing.
I had a syntax error. That's quite unfortunate.
Well, your top is 10, correct?
Yeah.
Yeah? Okay.
I don't have a syntax.
How do you have a syntax error? And then whatever the bottom is.
I definitely got not that. I'm sure you're right. Yeah, I got negative. I got negative 10.43. But that's not
It can't be.
it should be less than
Oops, because I forgot something. What did I forget in the denominator?
75 times that.
Yeah, I forgot the I forgot the.
Son of a nutcracker.
I forgot the beginning balance, didn't I?
So it's plus 75.
Yeah, we should get plus 75 in the denominator.
Now I got negative 2.74. I got 22.
All right, let's give this a shot. For heaven's sake, come on. There we go. All right, so your denominator, 75 minus 50 divided by 12 minus 12.5 minus 400 divided by 24 minus 70 divided by 12, and then plus, what did we say that was, 55? And then divide that by 10. No. Yeah. Well, yeah, I know. I'm going to flip it. There we go. I got 11. Or a hair over 11.
We'll get there. Can you move your screen over?
You want this moved over?
Yeah.
This was 90 point something on the denominator.
I also got 11.
Woohoo! There we go.
I did the fraction first, if that helps. The denominator first name, so it's a really long ugly calculation.
It is a very long, ugly calculation, I agree.
I forgot to multiply the summation by 10.
There you go. All right, if you were... Grace gives up, I think. If you were to do this in your cash flows, just to tell you what you would have to do, it would be tricky, but you could do it. You could get there. It just would take a lot of typing. Okay. Here's why it would be harder to do in this case. The reason why this would be hard to do, and it won't be exactly 11, because you remember your cash flow worksheet and your internal rate of return button will give you the honest to goodness approximation, not the simple interest approximation. It'll solve it numerically and give you a numeric approximation that's very, very accurate for the internal rate of return. The thing that really makes it, throws a monkey wrench in there, is the fact that they put this withdrawal out on the 15th of October. Because as soon as it did that, I have to make my cash flows on the half months. Which means that I have to do 24 cash flows. Which would be a pain. Not impossible, but as soon as they put it on this half month, I have to make it every half month for my cash flow, and then convert my half month interest rate to a yearly rate. Not impossible, but I don't really want to type in 24 cash flows. Just to show you how it would have to go to start, just kind of illustrate that I really wouldn't want to do it, as if I haven't convinced you enough of that yet. You would put in your 75 as your beginning balance. Your first cash flow would be January 1st. January 15th, there's nothing, right? So then you'd have to change the frequency to 1. Then on January 31st, you would put in a $10 deposit. And then, oh crud, I need to go back. Or I gotta make this negative. I gotta think about putting out money for the 75 and then taking money back for withdrawals. So I do the opposite signs between the two. All right, beginning balance is a beginning deposit, nothing January 15th, $10 deposited January 31st, nothing February 15th. And then what happened on February 28th? You took out 5 but put in 10, right? Both of those things would have happened on February 28th. So that would be a net of $5 deposit, right? And then you would keep going 24 times for each one. And again, the reason why this one's more complicated is I think they did this on purpose so you wouldn't do it in your cash flow. Because if that weren't in there, it would be pretty straightforward because your flows, your other flows would have been monthly. You can do 12 pretty quickly, right? So my guess is they did this on purpose so you'd have to remember your dollar weighted formula and not use your cash flow. Yeah.
But if we were doing a cash flow, this isn't for this question specifically, but if we do flip our signs on deposit withdrawals,
As long as they have opposite signs, you should be fine.
it'll just give it a negative.
You should give it a negative internal rate of return.
I didn't know if it would like give you an error or something, so it'd be a negative.
No, it should be fine. And all it's doing is just making it, it's just making a polynomial.
Right.
So basically all you do by flipping your signs is putting the polynomial on the other side.
Yeah.
So, in fact, it may not even give you a negative, I think it is the same answer.
Right.
So all it should be doing is just moving the polynomial to the other side of the equation. Okay. You should get the same root.
Makes sense.
Yeah. So in this one, you could, if it weren't for that stupid withdrawal on the 15th, you could have done this monthly and then 12 cash flows, which isn't that nasty. It's half the work. Okay. If you were going to do that way, you would still need to do net cash flow on a particular day. So for example, on this October 31st, you would put in a positive 25 because you deposited 10 and took out 35. So you were taking back $25. So you still have to do net cash flows on those days. Does that make sense? All right. Anyway, that's how you would do it on a calculator if you're going to do it. And again, if you've got a small enough problem, you should get the same answer. Well, I mean, not same. It should be really, really close to each other. Okay. And again, the whole point of that is because the simple interest approximation is pretty good if you're just doing it for a year. Anyway, all right. We'll do more stuff next time.
We don't have class Friday.
Oh, correct, right. We don't have class Friday, so I'll see you Monday.
We have another perspective factor.
Yeah. Yeah. Monday.
There's that biology guy come in last semester. He's pretty interesting.
Here it is. Those are the problems that I assigned.
Don't worry, Dr. Stowe, I got the calculation. I figured it out.
Did you? Excellent.